Hi, Mitt.
Hi, Don.
Hi. I'm promoting, I just promoted you and I got to promote submit.
Hi, Don.
Okay, so I've got all of you now. Oops, I need to do something here. Now I'm finding out. Mute the live because it's delayed 20 seconds. Are you guys all there? Amit and Sumit are on mute.
I
There's
am.
Amit.
Sorry, I was on mute.
No problem.
Is
And
this okay? Am I sounding okay?
yeah, you do. Amit, can you say something?
Hello. Can you guys hear me?
Yeah, a little broken up. Can you say something else?
Hello.
Okay.
How are you guys doing?
Good.
Yeah, that sounds okay.
Arn doesn't have a mic. He has no mic. He only has video. Why don't you guys here? Let's just do something here. I'll stop sharing and
Yeah, let me try doing that. Okay, so
stop sharing. Come on.
I want to share this first.
I think I have to stop first. So
Sure. So this looks okay. All the slides are fine.
Yeah.
And then I have to, I think.
Can you see his there? Okay. Wait.
And the other thing that we really want to try out is this. Is this visible? Okay.
It is. Yeah.
Okay, cool. And then
The transition is
this.
not that smooth, but yeah, we can make out the slide.
Yeah, I think that's because there are too many translations happening, I guess.
Okay.
Is this visible better?
No. I mean, it was better last time as well. I'm just saying
Okay.
that when you switch between one activity, this one to another one, so it was looking a bit better on Meet. I mean, now it is
Okay.
fine. I mean, this is perfect.
Yeah.
Yeah, you can see that this is running
So we
RC6.
can start from here and then we'll just go show this.
Sorry, one more thing which I missed last time was, do you want to open the floor for questions after my slides, or do you want to jump to the demo
No,
first?
I think we should do the demo first, and then because questions can happen even on the Slack channel.
Okay.
But this demo we won't be able to show there. So
That's true. Yeah.
So we'll just keep it as it is, and then this. And let me stop sharing this. And so the other thing is that I have to stop video here. If I start video here, I think I can't start it here. Okay, the host has stopped it. So all right, Don, let me see if I can. Yeah, so video sharing is not allowed, Don? I mean, our faces are not going to be visible, or is that something that you need to?
I gave you permission. You should just turn on your camera.
Yeah, I'm trying to, and it's telling me you cannot start your video because the host has stopped it.
Yeah, same here.
Okay. I'm asking Christine, because I don't see.
You might be able to just in the right side thing, you have the participants. If you, I think, click on more, and there should be something there, I think.
Make host. Change you to a panelist. Maybe I need to make you a co-host. I'll give it a try.
Okay.
See if that helps. Are you now able to?
Yep. Yes. And with this, I think I can't start.
And I lost.
Yeah.
I lost our.
Okay, that's okay. So Amit, when I'm giving the demo, I have to stop my video on Zoom, and then only I can go and, so basically this. And
Oh,
then when I start, then you will be able to see this. But that's okay, I think. That's not terribly bad.
I still cannot see your screen.
Oh, you can't? Wait.
Nope.
Share screen. Yeah. This okay?
Yeah, yeah. It is visible now.
And then this fine. And then, yeah, so I think we'll just start from here.
Right.
And then go to the other one. Okay. I think we are okay, Don.
Okay. You guys.
Yeah,
can,
we just wanted to see. Yeah.
Sure. You guys.
Thanks very much.
You bet. You guys can come back in a little bit, and we'll work from there.
Okay. Thank you so much.
Bye bye.
Thanks,
See
Ron.
you.
Hey, how's it going?
Good.
Audio coming through all right?
Yeah.
Good.
That's John.
Yeah.
I see Todd. He doesn't have a mic.
Okay. And then for video, we're waiting for you to turn that on.
You can turn it on. Oh, wait. Let me make you co-host, and I think then you should be able to do it now.
Alrighty. And then Todd at some point will be able to turn his on as well.
Yeah, I just turned Todd on, but he doesn't have a mic for some reason.
Oh.
Todd, no mic.
John, do you hear me okay?
Yeah.
There you are.
Sounds like you've got an echo, Don.
Yep, I just got rid of it.
All right.
I'm managing 3 systems here to do this. So.
Oops. Yikes.
And I see
So I was curious from your view, Don, if I'm looking this way, am I looking at Todd in the video stream?
What I see. Unfortunately, I'm not unsharing my screen. Are you there, Christine?
Hey, Dom.
Hi. So I'm having a hard time getting my unsharing my screen here, it looks like, so that they can take over the whole thing.
So did you find the Zoom window?
No, I only see the participant list. I can't find the big room anymore. Let me see.
If you click on the top right, the top left where the Zoom window is, what happens when you click on that next to activities? Don, can you hear me?
Yeah, but something's wrong. Can't seem to.
So if you click on that Zoom drop down in the top left hand, what happens?
I don't have the drop down. Oh,
I can see it. Yeah.
yeah,
Whatever you do, don't quit.
right. So
It's saying it's
what I
over.
can't do is unshare this.
Okay. Why don't you try joining on your other device with your Linaro login? That way you don't stop the recording.
I can also try to share, which might drop the sharing out. So
Let's try that.
hang on just a second.
I don't know if you'll be able to overtake the host, which was the problem. But you definitely try.
I was briefly made co-host. So
I've made him
we'll see how
co-host.
that goes.
Oh, there you go.
And now I'm gonna stop it.
Perfect.
And hopefully
That's
we're
what's that.
back.
Hey, well done.
Yeah, Don. Good job, John.
I don't know
Don,
what I
if you
did.
just no worries. If you just want to join on a second device, that way, if you can't find this stream, it's okay. You can just leave it somewhere. But you're gonna need to obviously share your screen again later. So I would just mute yourself on this one if you can, and join on a second on your other device.
Okay.
That way you can still kind of maneuver.
Okay. Thanks.
Okay. I'm going to jump onto the other session, but just send me a message if you need anything.
Okay. Bye.
Thanks. Bye.
Now, I'd like to get rid of me. How's that? Just the two of you now, right?
Yep.
Just brought submit in.
Oh, I'm not going to be speaking. It's just the two of these.
Okay, well, go ahead and mute yourself then.
Yeah, of course. John, did you guys already try the side-by-side thing, or it's not happening? Or
I'm not sure exactly how it's going to show up. So.
I see it right now. You guys are.
There must be, for whoever is presenting, there must be some sort of a view that it's only speaker or gallery.
No, yeah, we tried that. It's
Okay.
do I need to pull anybody else in?
No, I think
Just the two of you?
just the two of them. Yeah.
Yep.
Okay. And I think we're ready. You guys ready to start?
Yeah, just waiting for the minute to tick over, so we're
Okay.
on time.
All right.
Alrighty. Well, hello. My name is John Stoltz, and I work for Linaro's Consumer Group. This session is going to be an interview kind of conversation style session. So please save any questions, and we'll see if we can get to any of them at the end. That said, it is a short 25-minute session. So if you do have questions, do feel free to ask questions in the Slack chat room. And then maybe later today after the session, Todd and I will be able to try to answer those. So with us today is Todd Chose, who works at Google on the Android kernel team, focusing on their recent efforts with the generic kernel image, or GKI. Todd, it's really great to have you here for this conversation. Thanks so much and welcome.
Glad to be here.
So I guess let's start off. At a very high level, can you tell me a little bit about the goals of the generic kernel image effort? What is it and what's being done? And why is it being done?
Okay, so there's a number of goals, but the overarching main goal is to deal with the kernel fragmentation problem we have. And the problem is that vendors take our common kernel and they add their secret sauce for their SoCs to it, and then OEMs take that and they add their changes, and the result is that pretty much every SKU of device out there has its own kernel. And that's what we refer to as the fragmentation. The issues that come out of that are that security updates become very labor intensive. If you can imagine, to get an update out there, thousands of kernels have to be updated with whatever patches are needed for that security issue, and then those need to be deployed to the field. We're wanting to move toward a world where these kernels are kept up to date with LTS, and so we want merges of LTS to come down. And the reason we want to do that is because we have found that a very high percentage, over 90% of the security bugs that are found, are already fixed in Android Common by the time that they're found in the field, and that's because we're keeping it up to date with regard to LTS. And so we want to keep these kernels flowing and getting updated, and the fragmentation is really in the way of that. And so that is the driving issue that is motivating GKI. There's other things too, like cleaning up the ecosystem code, where right now there's a lot of kind of expedient changes that have been made in various of the kernels, and by doing GKI, we're making it easier to merge LTS by aligning more closely with upstream in terms of the core kernel, at least, and pushing the changes that are specific to SoCs and hardware out to vendor modules instead of having it in the core kernel.
All right, so I guess moving to this kind of more modular style kernel, how does this effort kind of differ from modular kernels that Linux distros have been using for decades now?
I think the big one is that we're, as I mentioned, it's motivated by security updates and being very aggressive about it. And what we really want by using LTS updates is to get the fixes out there on devices before they're even discovered. So we have found with our Pixel experience that oftentimes when the exploits are found and reported, that we've already got the fix, that the exploit could not have been done on a Pixel phone because it already has been updated. And there's a few others in the ecosystem who have been with us on that, but for the most part, the devices are not updated, and so then they're vulnerable. If you look at the big distros, they do not take LTS. In fact, they don't even choose the long-term supported kernels to do their distros based on. They rely on the CVEs being, security issues being identified and fixed, and then taking those specific fixes. And so there's this sort of fundamental motivational difference between the two. And so in there, another big difference is that we know who our consumers are. And so we can do things like have our partners submit symbol lists so we know which symbols that are part of the kernel ABI are actually used. And so those are that subset, instead of maintaining 30 or 40,000 exports as stable, we can just maintain a small subset, a small number of thousands as stable, as opposed to Red Hat, where they maintain the entire namespace of exported symbols as stable, which makes it very hard. It makes it impossible for them to just take LTSs, and so they don't, and they are very resistant to change because they're maintaining such a large, complex surface. So those are a couple of the differences.
So yeah, I guess kind of digging a little bit more into that, touched a little bit on it, but in the upstream kernel, there's been this big to-do about the fact that, the kernel does not have a stable kernel ABI. And there's a documentation file named stable ABI nonsense that kind of outlines this rationale. So, kernel modules are kind of classically tightly tied to the kernel that they're built with, and you can't just kind of mix and match. So how do you manage to keep these vendor modules working with the generic kernel as that generic kernel gets updated?
Okay, so there's kind of two main aspects to that. The first is, one of the things that can change the ABI is the build tools. And so one of the things that we are doing is we have what we call a hermetic build, where when you check out the kernel repository, you check out, in addition to the Git repository of just the kernel, we package it as a repo with several repositories that include the tool chain and so on. So when you build it, when partners build drivers, they're building it with the exact same tool chain that we have, and we maintain that very carefully. We also have a bunch of tools that began at Red Hat for similar purposes that are watching the ABI. So we describe the ABI, and it can catch changes that affect any of those symbols that we are maintaining as stable. And we have that baked into our pre-submit process for the kernel, so that we can, once we've declared that this KMI is frozen, we can detect any change that is going to break it. And obviously we don't take those changes. They either have to just be dropped or refactored so that they are compliant to the KMI definition. I should define my terms. So KABI, kernel ABI, is the full surface that drivers have access to. We trim that down, as I mentioned, to just use the symbols that partners actually rely on, and that is our kernel module interface, KMI. So when I refer to KMI, it is the subset of the ABI that we are actually maintaining as stable. And just to refer back then to your stable ABI nonsense, the writer of that article was Greg KH, and he is actively involved working with us on this, and he is supportive and does believe that this is going to work out. So
Nice. So I guess what sort of impact does the GKI have for Android device and SoC vendors?
So there's kind of a large impact on, especially on some of the internal processes, because as you can imagine, with the frozen KMI, that does restrict some, that takes away some flexibility that vendors may have to do, and it forces them for changes that are absolutely needed in the core kernel. They really have just two options. One is to send them upstream, which is the preferred option, and we are often recommending that. And if you, over the last year, as we've been working on this with vendors, there has been a huge uptick in vendors submitting code upstream to be included in the core kernel. And in fact, it's been one of the things that's been really awesome is to see cases where Qualcomm, or I'm sorry, where one vendor will ask for something. I'm not going to be specific here, but one vendor will ask for something, and as we look, they find that another vendor has already submitted what they want upstream, and they say, "Oh, cool, we'll use that." And so we're already seeing kind of synergy in some of this. Now, there are cases where stuff can't go upstream, and there's a number of reasons for that range from schedule pressure not allowing us to wait for the time, in which case we sometimes say, well, submit it up there and we don't have to wait for it to land necessarily, but we want to see the discussion. To other cases where the changes really aren't going to fly upstream, and the examples of that are kind of in the domain of out of tree kernel modules, which are very much discouraged upstream and actively inhibited in some cases, whereas this is actually something that we are encouraging at our level, because what we're looking to do is to push the proprietary code that's been in the core kernel to support hardware and so on out into vendor modules, and just the timing is such that all that stuff can't go upstream first. So to support all of that, their second avenue, in addition to upstream, is to submit directly to the Android common kernels. And so if you look closely, you'll notice that our number of out-of-tree patches in some of the Android common kernels has gone up significantly through this process. So we think of that as we're taking a lot of the technical debt that exists in the ecosystem, and it's getting pushed up and being made visible in the Android common kernels now, where ultimately we're going to start working off that debt and either getting it upstream or dealing with it in some other way. But for partners, there's a pretty big impact in their processes and how they do things, and there is some complexity in maintaining and adhering to the KMI interface that we have that has to be stable once we have frozen the branch.
Alrighty. So with Android 11 just recently released, kind of where's your team with the GKI effort? Are folks going to be finding GKI kernels on their Android 11 devices within the next year or so?
Well, you'll see within the next year, you'll see evidence of it, but you won't see true GKI kernels, because what we're doing at first, and what's happening right now, is in Android R, which just went public. The GKI, it's what we're calling GKI 1.0, where the kernels that ship as products are not our GKI kernels. They're product kernels from the vendors, but they have to pass compliance tests with Android R this is true of 5.4 kernels and higher. So if it's below 5.4, it's not GKI at all. But for 5.4 kernels at all and higher, or 5.4 kernels on R, they have to pass a compliance test for the certification that replaces their product kernel with the GKI kernel, and they have to pass the VTS and CTS tests with it, and then their devices can ship, which means that the product kernel is compatible with the KMI that we've defined. And so what you will see in the field are devices that you could replace the kernel with the GKI kernel, and you could replace the system image with the GSI system image, and that should be a usable device.
Okay. So do you have devices that have passed that compliance step already?
We don't. There aren't any in the field yet, but there are some that have passed. So the 5.4 kernel, the devices with 5.4 kernels haven't hit the streets yet.
Okay. I guess, do you have any kind of details of issues that vendors are hitting and trying to comply with the GKI conformance requirements?
Well, I think the biggest one is just the changes I already alluded to with regard to their development processes, and if you're used to just being able to go hack up some patches and put them in the kernel, and now you have to go through a review process with either upstream or Android Common or both, that looks like friction, and it slows you down. And so they're, the process has been have been getting adjusted, but I think it's been certainly a pain point. And another, related to that is some loss of flexibility or perceived loss of flexibility. There's really no loss of flexibility if they're trying to do some kind of value add that can be isolated into a vendor module. But if they have a vendor, some sort of a value add that is part of that needs changes in the core kernel, it becomes heavier weight, and so there's, we're sort of working through, and we're adapting too. So it's kind of been a learning process over this last year with our partners to sort of get to how do we complete this in a way that works for all. And we've learned a lot, and a lot of things have changed, and a lot of assumptions weren't quite what we thought. The other complication is just the restrictions that come with keeping their product kernel up to date with regard to the KMI as it changes, and the potential for merge conflicts when LTSs come and so on. And so we've been kind of working through that with partners. But those have been the biggest things.
So, it's obviously very early days, but, in practice, I guess, how has the kernel ABI stability gone so far? Has there been any kind of surprises where some small change ends up having a big KABI impact? And what have you done to kind of handle that?
Yeah, so there have been some surprises, sort of dealing. So we leave mod versions on because it's very valuable to catch. So we have, as I mentioned, we have these tools that catch it at the source level, look at analyzing the impacts of ABI. But sort of the final check is mod versions rejecting a module if there's a CRC difference. And we've had a bunch of surprises in that domain where just sort of the way things are declared, where the interface hasn't actually changed, but the visibility of structures maybe has changed, changing the CRC for a module, even when it doesn't look like the interface has actually changed. And so there were a number of issues in that regard where we thought we were maintaining stability, but in fact the CRCs were changing. And so we've had changes in tooling, we've had changes in process to deal with that. And I think we're mostly past those sets of issues. And we do have, so right now we have one branch which we are maintaining KMI stability on, which is the Android 11 5.4 branch, which is basically 5.4 for Android R. And I would say generally it's been going pretty well in terms of, for example, merging LTSs. That has not really had any significant difficulty with it. It's a potential, there's certainly a potential difficulty where some patches that are part of the LTS could affect the KMI. And our approach to that is to either, in some cases we can drop the patches because they may not be relevant for Android. In other cases, they have to be refactored so that they are KMI compliant. And in order to facilitate that, before we froze the branch, we went around and added a bunch of structure or elements and key structures that could be used for that kind of refactoring. But generally, it has, has gone pretty well, and we haven't had huge issues.
Nice. So I guess, what are the next steps for Android 12 and after? I mean, what plans are there beyond just the conformance testing?
Yeah, so Android 12 is where we go to our what we call GKI 2.0, which is where GKI kernel is actually shipped as the product for on these devices, and so that begins with 5.10 or whatever is this year's LTS. It looks like it's going to be 5.10. So that looks like it'll begin with Android 12 and the 5.10 kernels. And so the big challenge going beyond, to ship it as a product compared to just the compliance testing that we're doing in R, is that now it has to have all of the product polish. It has to perform. It has to have good power characteristics. We have to be more mindful of the size of the image and not bring in unnecessary drivers that consume memory and aren't useful. So all of these are the main focus for GKI on the technical side, and then there's a lot of process work as well with partners as we're working out how to deliver it, how to deal with the need for rapid bug fixing and that sort of thing. So there's a lot of complex process work as well. So that's going to keep us pretty busy for the next year.
I guess, is there any issues that you're particularly worried about for the next step that vendors should be kind of watching out for as they make their plans?
Yeah, well, I guess I mentioned the performance and power, and I am, one of our areas that we're watching and figuring out how to get good feedback is, making sure that when we deliver an update, say the next LTS with the GKI kernel, how do we make sure we haven't regressed some corner cases? I mean, there's kind of the obvious corner cases or the obvious cases we're going to catch up front because it'll be well tested, but some regression that only affects certain hardware and certain use cases, getting the test matrix such that we can catch stuff like that with the help of our partners. I think that's sort of it's not completely figured out, and there's some concern there of how do we get there. I do believe we're going to get there, and we're kind of, but it's not something we can do by ourselves because we're not going to have all the SKUs of all the devices. It's something we need to do along with the whole ecosystem.
So now, I guess while being able to kind of update kind of the core kernel is going to be like an amazing improvement for security. When you do kind of look at the monthly security reports, there still are a lot of issues that are in vendor-specific drivers. Are there any kind of GKI-related efforts that you're thinking about that would help kind of close the gap there as well?
So for now, that domain of fixes that need to be applied to vendor modules is really in the domain of the vendors and the OEMs, as it has been. So I see us focusing on that once we sort of get over this first hump, and then working out how do we streamline the delivery of fixes for vendor modules as well. So for in the short term, I see that as something that we're really encouraging, just like we're encouraging today, for OEMs to do updates of that. But that one is that's sort of the next round of the security issue.
Okay. So I guess another aspect I'm kind of curious about is like, how much is a vendor going to have to be involved in participating with kernel updates with the generic kernel image? For example, if a vendor essentially abandons a device, is that device still going to get kernel updates, or is the vendor always kind of in the path for the updates?
So the vision, and I can't comment on how long it will take to get to the vision, or precisely how the vision is going to be realized. But the vision is that they would not have to participate at all, that it could be delivered directly by Google or via the OEMs, via some mechanism that that participation could be very light to nothing. That will take a little time.
Yeah. Alrighty, so that's I think all my questions. So Todd, I just wanted to say thank you so much for joining us and sharing your thoughts on kind of the recent and future directions of the Android kernel efforts. It's been really exciting to hear about it, and it's been really exciting to have Linaro kind of be a part of the effort as well. So thank you so much again.
I mean, it's been awesome to have your partnership in all of this. You've contributed quite a bit.
Alrighty, maybe we've got 2 minutes. I don't know if we have any questions. I can take a peek real quick. Question is there a possibility any GKA1 devices get bumped to GKI2 by the vendor?
Very unlikely. And that would mean going from a 5.4 kernel to a 5.10 kernel, which making such a transition is extremely rare in our world, at least at this point. But we do expect further down the road that changing the major version of the kernel on a device will not be so difficult. You know, when you imagine that the core kernel doesn't have much vendor specific stuff, and so it's really just rebasing the drivers, which isn't trivial, but is a much simpler problem than it is today. So we do expect that will be something that can happen. And you know, if we look way down the road, we hope to actually trim the number of Android common kernels that we have to keep live because they can move forward on the major version as a result of this GKI work. But again, that's way down the road.
Alrighty, well, thanks so much. I think we're out of time. So again, thanks for joining. I really appreciate it.
You're welcome. Thank you for having me.
All right, I've got to jump over to the next session, so I'll catch you later.
Okay, I'll take off
Thanks
too.
again.
All right.
See you guys.
Bye.
Thanks.
Don, should I just start sharing my slides, if that's okay with you?
Sure, that's fine. I'll go ahead and.
Okay,
Yeah, go
and
ahead.
I can't still start a video. You might need to make me a co-host or something.
Oh, yeah. And who else do I need to pull in?
That'll be Amit, John, if Tom's there, Tom, and Yunkin.
Okay, I see a net. Amit and Yonkin have now co-hosts, so they should be able to share.
Thank you. And I think John should get in here as well.
Oh, hello, everyone. Can you hear me?
Yep.
Yes.
Don, do you mind allowing my video to play?
You should now.
Alrighty.
Can you?
Yep. So let me start.
Perfect.
Okay, we've got about a minute to go, so let's just wait that out.
So it looks like I need to bring in Tom.
Yeah, Tom should be good. If Yonkin is here, Tom might not be speaking, but it should be good to have him as backup if required.
Okay. Done.
And I think we should start.
Right.
So, okay, here we go. Hi, everyone. I'm Sumit Simwal, and welcome to the session of lightning talks from the Linaro Consumer Group. We have Amit Pundir, John Stoll, Sam, Tom, and Yunkin as well in the team. So a very short agenda. It's I'm gonna give very super short pointers about the plumbers and the Android micro conference that happened there and how it went, what you should definitely go and check out. John will update us on the ASP dev boards. Yonkin will talk about the Android LKFT, and then we will end with Amit talking about form factor efforts on the Poco F1 and Pixel 3. We do have an exciting demo lined up at the end, so do stay till the end. Okay, let me jump right over to the Plumbers Android Micro Conference bits. It was a long micro conference by any standards. We had 16 sessions, 4 hours of micro conferencing, and then an additional 3.5 hours of follow-up discussions. So you can go and check out the full schedule with slides and video links at the link given here. The follow-up of the BOF, the follow-up BOF can be seen at the link over there. As to what got talked about, I think the highlights would be the GKI sessions that Todd and others spoke about. Then we had Saruna talking about the firmware dev link and its upstreaming. Loha talked about integrating community projects into ASP like Mesa and libcamera and so on. And there was a follow-up BOF discussion as well. Then Som went on to talk about bootloader consolidation, and there was some very nice discussion around eBBR, UEFI, U-boot, and what can be done to make things easier for people. There's a follow-up BOF discussion as well. We even had a session from someone at Microsoft on SE policy, and this really goes to highlight the growth of the community as it has happened around Android. In addition, vendor hooks setup was discussed and introduced first time to the community, incremental FS and updates, DMA buff heaps, the current state of Android patches. These were some of the things that got talked about. So I would really urge you to go and have a look at the full schedule, slides, video links, and feel free to connect back with us if you have any questions around that. Thanks to the Android Micro Conference organizing committee, which was instrumental in getting this done. So over to you, John.
Alrighty. Hi, my name is John Stultz, and I'm going to talk a little bit about AOSP dev boards and just kind of update the status on that. Go ahead to the next slide. So when we talk about AOSP dev boards, we're talking about the Hikey 960 and the Dragon Board 845C, which are both 96 boards that are supported in AOSP. And these are basically our kind of test vehicles that we use in order to test the latest AOSP userless base code with the latest mainline kernels. And we're able to do that, every RC1, RC2, et cetera. And that actually manages to catch a fair number of regressions that, hopefully we're able to catch before other people run into. With these boards, we are also able to test LTS stable updates, which I think is really important because that helps ensure that any vendors who are picking up those LTS updates for their devices can have some confidence that, there aren't new regressions that are sneaking in. But I think also a really, on top of just the testing, an important part of these boards is that they become kind of a platform for prototyping and validating any sort of new functionality that we want to add or try in AOSP. And we can do that against the mainline kernel, which makes it a lot easier to push that code upstream. And we've used that recently with a lot of the GKI prototyping work, as well as the recent DMA buff heaps effort in order to transition off of Ion. And we've also seen inside of Google these boards be used for things like the UFS inline crypto engine enablement, where that was done against these boards, and then those patches got very quickly submitted upstream. I guess next slide. So diving into the Hikey 960 a bit, this is sort of, I guess, the test workhorse at this point with the kind of broad coverage of a number of older kernels. So it does the Android 4.14, 4.19, and 5.4 kernels. At the moment, there is no support for Android mainline. This is because Google is preferring that they would like to see the remaining patches that are out of tree be upstreamed first rather than carrying them in their tree. So this has the potential to make it that Android 12.5.4 may be the end of the line for the Hikey 960 kernels in AOSP. We'll have to see. Upstreaming, unfortunately, has been very slow recently, basically with HiCycling not being involved over the last year plus. That said, we have done some upstreaming ourselves, and we've gotten the USB gadget support recently merged upstream, but we still have outstanding patches for the USB host mode, basically, as well as the DRM display and audio drivers. Also for this board, we are still using the Mali binary driver. Unfortunately, we just haven't had enough time to spend to try to enable Bifrost on this, but that's something that we still would love to see. One bright spot, though, is that apparently HiSilicon has hired Maro Chiab to push some patches upstream on the mailing list. And now he's focusing on doing the Hikey 970, but that shares a lot of the same IP as the Hikey 960. So we've participated publicly on the list to take some of those patches, try them out on the 960, provide some feedback, make sure they continue to work. So there is some possibility that we may see some of the missing functionality still land upstream yet. All right, go ahead, next slide. On the Dragon Board 845, over the last 6 months or so, we've been able to gain Wi-Fi and HDMI audio support, which is very exciting. It's supported with the Android 11.5.4, Android 12.5.4, and Android mainline kernels in AOSP. With the Android mainline and upstream kernels, it basically matches the Hikey 960 with functionality. So this is kind of nice to have this board kind of up and parity there. Now, thanks to the Qualcomm landing team, the upstreaming on this is in a really good place. The only patches that we have out of tree at this point is the HDMI bridge driver, which is already pending in the next kernel, and so it should land in 5.10. And then Bjorn has a SMMU and IOMMU series that's required to boot. And that's really it. With those, you can boot the device and kind of get all the functionality that's there. We do have a handful of patches that are related to GKI and the efforts there that we've done. And these are basically modularizing upstream drivers. So drivers that are already in the mainline kernel, just enabling them to be built as modules. And so that's something that we have still a series of patches to work on getting upstream. And this board also has been a really important, basically a launch pad to help with the Pixel 3 and Poco F1 form factor work that's you'll hear more about later. All right, next slide. As far as what's next for the dev boards, we're going to keep doing our testing and validation of upstream kernels on the latest AOSP. We're going to continue pushing patches upstream. There's of course, issues and bugs that we want to solve with the CTS and VTS. One area that we've been maybe a little negligent on is performance tuning, and so I think that should be something that we need to spend some time on the user space side of. And then on the Dragon Board 845, we have accelerated video decoding that we should be able to enable here soon. And then also there's work going to improve the camera IP blocks on the board. So hopefully we'll be able to get something like a camera HAL working on it. As far as new boards, I think we're always kind of keeping our eye out for what's out there, for what might be next, what sort of features we're looking for. But we also kind of have to keep a little bit of a skeptical eye on this because, it does take a lot of effort to enable a board and get it working in Android. So basically, if we are basically resetting every couple of years, to build up a new board, we don't get to spend as much time doing sort of more of that development work on top of the platform. So we have to be a little bit cautious there, but it's one of those things where we'll kind of, ideally, if there was a board that was already upstream, this would make this a lot easier. And then we have to kind of weigh that features versus cost versus availability. But we will be, of course, keeping up with new things. So I think that's next. I think that's it for me. So I'll pass it on to Yonkun. Thanks.
All right. Thanks very much, John. And Yonkun, off to you.
Hi, everyone. I'm Yunqi Liu from the Linaro Consumer Group. Here, I will give you an update on the Android Archivity project. First, is about the builds. We have more than 40 builds set up for this project. They cover the kernel versions from 4.4 to 5.4 to Android mainline, and cover the Android versions from 8.1 to OSP master, including the Android 11 just released this month. The builds also cover both the 64-bit platform and the 32-bit platform with the DB845, Haki 960, and the BeagleBoard X15 both. Okay, next slide, please. Here is about the test we ran for this project. We have boot CTS Archivity, VTS kernel test run for all the builds. We also have the CTS pre-submit test plan run for the DB845 only. The CTS Archivity and the VTS kernel test have about 63,000 test cases. Besides that, we also have the full CTS and full VTS test and some benchmark test run with the DB845 and Haki 960 builds bi-weekly. The full CTS and the VTS test have about 1.26 million test cases. About the benchmarks, we have boot time test and the other 15 benchmarks like the benchmark Pi and Tutu applications. Currently, we mainly focus on the failures reported by the boot test CTS Archivity VTS kernel with the highest priority. Okay, next slide, please. Here are some issues we have with the test and the builds. First problem is the boot failure problem, which is often caused by the ABI broken problem with the JK kernel. The next problem is the ADB connection lost problem. This problem often happens after the reboot during the CTS VTS test. Currently, we resubmit the jobs to try again manually to work around the problem. There are often network DNS-related failures reported by the CTS WebKit lab core models. There are also a huge number of failures on graphic and media reported by the CTS DQP and CTS media models. For the builds we set up, we needed to maintain the out-of-tree patches for the platforms that's not supported by the Android Common Kernel by default. The out-of-tree patches mainly include the DTS files, external models, and changes that's not still not accepted by the upstream, like the DRM changes for Haki 960. Okay, I think that's all updates from me.
Thanks very much, Yangchin. Let me now invite Amit to talk about the form factor efforts. Amit, over to you.
Hi, this is Amit. I will be giving quick updates on LCG efforts to run AOSP with the mainline kernel on form factor devices. Next slide, please. But first, I will start with a quick recap on why we put so much emphasis on form factor devices. So we have been chasing this one for a long time now, and you can check out John's previous presentations for the rationale and our previous efforts. The key takeaways are that it helps us avoid dev board functionality gap during development and testing. And secondly, it helps us validate and compare upstream solutions with the vendor solutions on the same hardware. And to be frank, working on a shipping consumer device is much more exciting compared to a dev board. So no more dealing with add-on mezzanines or capes or hats for extended functionalities. Next, please. Right, so now to the main topic in hand, that is running mainline on a phone form factor device. As John mentioned in his slides earlier, DragonBoard 845C has a really good upstream support. So Pixel 3, which is based on same SDM 845 SoC, was the obvious choice to leverage this upstream support. But we soon hit a wall with display stream compression support, and we do not have a working display yet, something which we are still working on. Luckily, a couple of us had access to Poco F1 phones, which is another SDM 845 device. And building up on our Pixel 3 experience, we got mainline booting on Poco F1 in a very short time. We have already covered it in details in one of our previous blogs. The link is in the slides for that. Next slide, please. Overall, running mainline on Poco turned out to be a good community project, with mostly us pestering our Qualcomm lending team or upstream kernel and Mesa developers every time we got stuck at something. Post-market OS guys were working in parallel as well to bring up their OS on SDM 845 devices. So we end up exchanging notes on enabling further features. From upstreaming point of view, we are making a good progress as well. Again, as John mentioned in his slides, Poco F1 is blocked on missing SMMU bootloader mappings as well. Qualcomm Lab IBB regulator is already merged. Base device tree is in Q4 5.10. And as you can see, we have few drivers and fixes which are up on LKML for review. And then there are some which are currently being worked upon, like touchscreen and audio amplifiers. Next slide, please. We have uploaded a video of mainline kernel booting on Poco F1. It runs 5.9 RC1, but we do rebase our tree with almost every RC. So please do check out the README page for instructions and how to get started, because a lot of it is still in a to-do list, as you can see in the slides below. Next, please. We also have Android GKI booting on Poco. Again, since we already had GKI booting on DB845C, sorry, Dragon Board 845C, we got a head start. But it did require few downstream driver changes to build and load them as modules, and a few changes to work around the restricted ABI symbols list, which John and Todd mentioned in previous session. Next, please. On Pixel 3, there are no new updates as such since last connect. We do routinely test mainline kernel-based AOSP builds on that. And Pixel 3 is still our primary platform to validate core downstream drivers like LabIBB and GPI DMAs, etc. And we help push them upstream. We're also working with Qualcomm Landing team on DSC support. So if you are interested and want to contribute, then please check out our wiki page for instructions and FAQs. Next slide, please. And it is demo time. So over to Sumit for the demo.
Yeah, I'll have to stop sharing this for just a sec and I'll start the demo. So what we have here is a video call going on Jitsi, which is also being seen here. What we see here is the Poco F1 phone. And if you see, there is the, it's running Android S, but running 590RC6 based kernel. And the build is of yesterday. And there you go. That's running the conference that I was talking about, which is what I'm sharing right now. So we're able to. Oh, what happened? John, you were waving and suddenly you went away. So I can see you wave on this. Let me see. Okay. For some reason, I don't see John here. Oh, there you are. So yeah, that's been the demo. As you can see, touch is working, Wi-Fi is working, video decode is pretty good. So yeah, that's been the demo. Let me just stop sharing this. And if there are any questions, we are any questions? Let me see if there are any questions on Slack. So Sahaj asked, is there any interest in, okay, John's already answering on Slack, so I don't need to go around here. Thank you, John.
We can actually repeat the question for the audience since it is recorded live, right?
Yes, we can. So Sahaj asked if there's any interest in using the RK3999 SoC, 3399 SoC for ASP. And John said it's something that we've been watching. Ulf had a question about in these various Android devices, do you know which ones that uses the STI interface for Wi-Fi? That's the Hikey 960. Those are the only two questions that I see here right now. Any questions here? No. So I think we're good. Okay, if there are any questions, we'll still be on the 304 chat, and we'll be on the general hallway chat. So please ping us there.
All right. Thanks, guys.
Thanks
so
very
much. Appreciate it.
Thank you.
Hi, Paulo. And Anders. I don't see a mic for Anders. I've promoted you both to co-hosts so you can take over the screen. Paulo, if you can hear me, let me know. You're on mute at the moment. There you go.
Yeah, I can hear you. Yeah.
Great. And at any point, you can just go ahead. If you're going to share a presentation, you can go ahead and grab the screen now and pull it up. It'll just take over. And again, Anders, I see him on here, but he doesn't have a mic. There we go.
No.
Hi.
Yes. No. Hey there.
Hi.
That seems to work.
Yeah, everything's good. We'll start up in 9 minutes. I'd encourage you just to go ahead and whoever has the presentation to share it and take over the screen now.
Yep. Is Paulo online?
Yes, he is, and he just went back on mute, but he can talk as well.
Okay.
I have only a problem with Slack. I mean, I didn't make it to sign in. I don't know. I tried to create an account and so on, but there is some issue. So I didn't make it. I don't know whether it's something I could do quickly, but yeah.
Okay. Let's go back to mute.
Can you see that? Or how do I go to full screen?
Yes, if you just hit present, you'll be good. Top right by the share button. There you go.
Done?
Yes, sir.
What about my camera? Is it better if I switch it on or? I
Sure,
don't know.
you can do as you wish. But yeah, I think the camera is a nice touch, and if you do that,
Yeah, it's better.
you
Yeah.
went out of presentation mode, but you should be able to enable your camera when we get going.
Yeah. Okay.
In
Thank
4
you.
minutes, and you'll show up on the screen. In the corner.
Yeah. So we have 25 minutes total, right?
Correct.
Okay.
And let me just verify. Yeah, we're scheduled to start 25 after, so you've got 3 more minutes. I see no attendees have joined yet. So. And I'll just let you introduce yourselves right at 25. You can just say welcome to the webinar and go from there. Okay?
Okay, so Anders, will you start?
Okay.
So yeah, you can probably both turn your cameras on and then go to presentation mode with the deck, and you'll be ready to go at 25. I see you both. That's good. I do not. The deck is still not in presentation mode. So whichever one.
I think it's better without.
I'm sorry.
I think it's better without camera.
No, you're a fine looking lad.
And you're beautiful.
Can you try putting the deck in presentation mode? Which one of you has the deck? Is sharing it.
I have it.
Okay. Perfect.
Yeah. Then Handel will take it over to me, and I will share my screen. Probably it's the easiest way to go.
Yeah, you are co-host, so you can just take over.
Is it still sharing? Hello?
Yes. For some reason, the right side is a little bit black.
Yeah, to me as well.
It's not rendering correctly. Do you have something overlaying that picture? Or?
No.
Okay, I think you guys are ready to start. And let's try to, since no one's on yet, this may just end up being a recording. Let's try to figure out why you're not sharing the whole screen. Or the presentation is half. I see that. And if you go back to presentation mode now. Okay.
Better?
Well, and it starts to, you may have to present from non-presentation mode.
Like that.
For some reason, it's not rendering. It's like half the screen is black.
Maybe as a fallback, I could share my screen. I don't know. Maybe it works.
If you have the same deck, I'd encourage that. Go ahead.
Do it.
And then we need to get going. We're a minute late, and I'll just let you start the intros. Once you've done that, just introduce yourselves and the deck, and I'm going to go on mute now. So you're going live.
So, okay. Sure. This one, I guess. And where is it? Whoa. Here. And present. Is it working?
Perfect. It's showing up correctly. So I'd say do your intro and go live.
Yeah, so Anders, you would just tell me next slide and I will execute.
Yep. Okay. Hello and welcome to the new IO benchmarking framework being integrated into LKFT. Yeah, next slide. And by the way, my name is Anders and my co-presenter is Paolo.
Hello.
Yeah, next slide. So first I'm gonna try to explain what LKFT is, and that is the Linux kernel functional testing. It's a project that Linaro is going to test all the stable kernels, and Linux Next. We run a lot of functional tests like LTP and K-self test and lib huge pages, to name a few. Yeah, next. So from here and forward, I'm gonna tell you a story about a Swede and a guy from Italy that is trying to implement some benchmark tests into LKFT, and where we ran into problems, and we run into a lot of problems. It's not like functional tests, but they are fairly easy. It's pass or fail. And benchmark testing is a bit different. First, you need to know what kind of hardware you have, and you need to know the peripherals. For instance, IO benchmarking, you need to know what kind of IO device you have, and if you have multiple hardware, you need to have hopefully the same brand of, for instance, SSD disk. Otherwise, they can fluctuate in accuracy quite a lot, and you will see that we had some issues there further on. But then, what can we mean by regression? That is, if the average goes up or goes down, of course, but we need to figure out for different use cases if it's actually going up or going down. That is the
Anders, your audio is breaking up a little bit, so perhaps try to get a little closer to the mic and see if that helps. Thank you.
Okay, I'll try it. Yep, next. So, first, back one, doesn't matter, but first step, we had problems running on the hardware. It crashed a lot, and we ran the S suite that is maintained by Paolo to see the different schedulers, how they behave. For instance, BFQ, and everything was hanging for us in the first step. And next step that we ran, we got some results, but they were basically all over the place, and the data varied up to 20-25%, and we can't say much about those numbers if it varies that much. So we thought we could do better, and we managed to do a bit better. Next, we ran the suite for multiple times, and that helped. So instead of 20-25%, we got down to 12-15% of differences, and we couldn't draw that much of conclusions from that either. So we had to do even more, and we had to rework the timers because from time to time everything did hang, and we had some hanging issues as well that we sorted out. And with regard to different hardware and different devices of the same hardware, we had a lot of interesting issues there that was the same hardware but different peripherals, and that made it also be a lot of differences. So we had to narrow it down even more, and we managed to do that with doing a lot more additions. We started off by doing too many, and then we finally narrowed it down to 3-4, and the data looks fairly good then. Yeah, you can take the next one, or yeah. So now we are trying to implement email reporting tool for this as well. That's to find the thresholds. We need to look at data from 20 or 100 rows and produce some sort of email report out of that, and that's where we are right now. And I think Paolo is going to talk a bit more about that. Paolo?
Anders, you're still breaking up pretty bad. If you could maybe adjust your mic a little bit or try a couple things. Maybe turn off your video.
Yeah, Paolo, it's your turn.
Okay.
Here I am. Okay, so I'll take it over from here. The second part of this presentation is, I want to show you some of the results that we have obtained using this HES suite, and I want to use these results to motivate the thing that we would like to do next. That is adding an infrastructure for analyzing performance, and in particular for detecting regressions. But let's go one step at a time. So I want to show you these results with this HES suite. I should have something ready here. So this is an example. Yeah. Here we go. So this is the test run for this build here. if we go to the bottom of this page, we can see the numbers that we obtained with this Hess Suite benchmark. I will explain you the numbers along the way. So if we click here, we see these numbers here. What are they? So one of the main tests executed by this suite is to just measure how long it takes to start an application, to see the responsiveness, to measure the responsiveness of a system. In this case, the test application is just a GNOME terminal. We measure this while there is some background workload being served. In this particular first and simple example, the background workload is just nothing. So we have this 0 here, but I will tell you about other workloads in the background. And finally, the other parameter is who is controlling I/O. So this is the test. We start an application and measure how long it takes to start, of course, with cold caches, because we want to measure something that has to do with I/O. Yeah, and we report that number. So from here, we see that in about 1 second and 1.3 seconds, we have started this terminal. This happened if there was nothing in the background. We have some statistics, of course, on this number, as Anders told you. So average, maximum, minimum, and the standard deviation. Of course, as you can see, the average, maximum, and minimum are more or less the same when you have nothing in the background, because, of course, almost about the same will happen. Okay, so this is the result that we get where if we have as I/O scheduler, we have the BFQ I/O scheduler. So this I/O is being controlled by BFQ. But in the I/O stack of Linux, we have 4 I/O scheduler. So we also have Kyber, then we have this MQ deadline, and finally we have Known, which is actually it's not an actual schedule. It's just do not control anything. If you have a look at the numbers, you can see that the time to start the application is essentially the same, whatever scheduler you have in charge. So with Kyber, we have about the same number that you have with BFQ, and the same applies to MQ deadline and of course to Known. So about the same value. Okay, so this is the base case. Basically, this is a case where a scheduler does nothing because there is just some I/O coming and you just pass it through and dispatch it to the device. Things get interesting if you have something in the background. You have some additional workload being served. This is the interesting case. And for this case, for example, this benchmark tries several cases. One of the cases is if you have, for example, 10 files being read in parallel while you try to start the application. This is somehow an extreme case to see how good an I/O scheduler is, but it does give you an idea of how good you are in controlling I/O. And as you can see with BFQ, the time to start the application is about the same as it was when there was no I/O in the background. So it's 1.5, while here we had 1.3. So it's interesting to compare BFQ with the other I/O scheduler for the same case. But if we search for the results with the other I/O scheduler, so with Kyber or MQ deadline and so on, we don't find any number. Let's focus only on this workload in the background. Results are essentially the same with the other workloads. So if we check all the numbers here, we won't find results for this same workload. Why? To find out, we have to go back and look for the suite and see the results, and we will discover that the tests with the other scheduler have simply failed. Here is Kyber with the same workload, the same test. So trying to start the GNOME terminal. Why did it fail? Because the terminal didn't start at all. So we found out that if we have some I/O going on in parallel, we lose responsiveness completely on this board. It should be an X15 and with this kernel. Okay, so this is a rather strong result. Results are along the same line as the one that I have just showed you. So this was the first thing that I wanted to point out. So these results, so with this suite, we can now measure rather easily the responsiveness of a system, and we already have rather interesting results. We know that, for example, if we don't have this BFQ I/O scheduler, then we lose completely control on this board if there is some other I/O going on. We may lose completely I/O because, of course, the situation is more complex than in a real scenario. So this was the first thing that I wanted to show you. The second thing is that I wanted to use this chasing of numbers to give you this impression of the fact that it is rather difficult to process these numbers. I think that you also had some difficulty in following me. So it wasn't that easy to find these numbers, compare them, and consider that, of course, you have been guided by me, and I already know these results. Let me just show you how easy it could be to check these numbers. Here they are. This is a very simple plot. We have the startup time for this GNOME terminal. Of course, this is on a different device, so numbers are different. We have in purple the result with BFQ. So when we have these 10 readers, we make it in about 5 seconds. We have this reference red line here that tells us how long it would take if the device was idle. And so we can see that we have, with BFQ, we have about the same startup time as if the device was idle. But if we switch to the other schedulers, we have this axis that just tells us that the application doesn't start. The test waits for, if I remember well, 60 seconds or even 120 seconds, but the application doesn't start. Then the test stops and declares failure. So as you can see, it's extremely easy to understand these results if we look at this simple plot, while things are much more difficult if we have to follow this page and jump between failure numbers and back and forth and so on. So this is the motivation for what we would like to add to this framework. We would like to add something that, in contrast, makes it very easy to analyze performance and to, in particular, to spot regressions in performance. So hoping that I have convinced you a little bit, here is our proposal. So the problem is that in Linaro's framework, currently there is no support, no actual substantial support for performance analysis or for detecting regressions. It is not easy to do performance analysis as compared to functional analysis, because in performance analysis results are numbers and not just pass or fail. There is no fixed criterion to say, okay, these numbers are good, these numbers are bad. And actually the best solution, not easy, but the best solution is actually to learn from results. So given this not trivial situation, here is our proposal. We want to we would like to add 2 components. The first one is a component that should make it easy to extract and download data using some generic format. Anders proposed me TEP 13 or TEP 14, if I remember well. Maybe then Anders can tell you more on this, so that users can download this data and they can use the tool that they prefer, or can even use multiple tools and compare results. So this is the first contribution that we would like to give. The second one is to actually also give our tool. So propose a tool for analyzing this huge amount of data that we obtain from these continuous benchmarks on several boards, several systems, several kernel versions, and so on and so on. So, so the tool that we want to propose, we have several ideas on how to make it. One possibility is to make something based on statistical analysis, where this is sufficient. Should complexity be too high to be handled with just statistics, then maybe we could try AI. So we can evaluate this. Regardless of whether we have statistical analysis or AI on the ground, beneath all of this, we would like to also add capabilities for easy visualization of data. As I hope I convinced you that that simple plot was much, much better than skipping among numbers. One extra feature that we may provide is some mechanism that allows a user, or does it on behalf of the user. So something that marks bad data, because that's another problem, a huge amount of noise in results. So something that somehow could help to mark bad data points, or even automatically mark them. Yeah, so this is basically what we want to propose. What else? To start doing this, we would like to use some benchmark as a concrete example for our first implementation. We were thinking of Hackbench, because this seems to be a rather widely used benchmark. Then we may move, for example, to our S suite, just because we know it very in depth. Maybe the cyclic test is another good option. So probably after we make this work on, I don't know, 3 or 4 different benchmarks, it's likely that we have something rather general, rather robust. And so probably it may work on maybe all the benchmarks available in Linaro's frameworks. Maybe after, I don't know, modifying a little bit the output of some of the benchmark. So the idea is to get to something that allows the user to actually do performance analysis and to be warned about nasty regressions. Okay, I think this is more or less all. So yeah, thank you.
Thanks, guys. Do you see any messages in the chat or questions?
Okay, messages. Probably I have to stop sharing to. Where is my chat? Chat. Okay. So yeah. Well, basically some complaints on the quality of the audio. Okay, I really need to fix it. You can go on mute. Okay, so yes, the answer to the only easy question is yes. I think that we have already uploaded these slides on Sched. So if I'm not wrong, they're already there. But I don't know, Don, if there is a better way I can share them, just tell me how to.
Yeah, I think they'll be part of, when we get everything pulled together, the slides will be included.
Yeah. At any rate, just send me an email and then we'll send slides back. I don't know, and any option is okay for me.
Okay, great. Thanks, guys.
Thank you.
Hi, Ashok. I've just given you permission to share. It looks like you're already doing that. You can go ahead and share your presentation if you want to and get it just kind of queued up, and we'll officially start at the top of the hour. Okay? You should be able to unmute yourself. There you go.
Sorry, yeah.
No worries.
Right, let me.
Perfect. You look good.
All right.
So I'll just go on mute, and at the top of the hour, you can
Yeah.
introduce yourself and go. Okay?
When do we start?
Let's let your clock flip to exactly the top of the hour, and then yeah, go ahead and introduce yourself. We're about 30 seconds out.
Oh, sorry. Yeah.
Okay.
Sure. Sure.
Okay. All right. Okay, I think you can go.
Hi, everybody. I'm Ashok Bhatt, Senior Product Manager at ARM, looking after open source tool chains. And today I'm going to talk about GNU and LLVM toolchain, what's new and what's next. And when I say what's new, this is what has happened in the last 6 months to 1 year in the various major releases. And when I say what's next, it's what's coming in the next 6 to 12 months. And this kind of includes not just what ARM has been doing, but kind of ecosystem view as well. So as we go along, you'll see areas where Linaro has been contributing and other ARM ecosystem partners have been contributing. I'll take a look at the Slack channel at the end. If you have any questions, we can answer that. All right, let's move forward. So what's the agenda? We're going to talk about the bare metal tool chain first. There I have an update on a GNU embedded tool chain. So this is one of the popular toolchain products that we ship, and it's kind of used as many IDEs and very popular in the embedded microcontroller market. Then I have an update or plan for LLVM bare metal toolchain. We'll talk about generally the architecture feature support in the last version of GNU and the next plan, what is planned for next version of GNU, and same thing with the LVM. Specifically, I'll talk about a bit about SV and SV2 support because this is one of the big items, and it's been a lot of heavy lift over many versions now. Fortran is a new entry, so I'll talk a little bit about what's going on in LLVM Flang and how the ARM and ecosystem and they're kind of working on this. Final set of slides. Maxim, who heads the toolchain working group in Linaro, has given me a few slides that covers what Linaro is planning to do in the next planning cycle, I think roughly 6 months. All right, let's get started. So first, the embedded toolchain. This is a free toolchain that we provide. We've been providing for quite some time now, and it covers bare metal use case, mainly on 32-bit ARM cores. So initially it was just Cortex R and M, so microcontroller class devices, but as of last release, which was done in April, I think, we started supporting even 32-bit Cortex A cores because microcontrollers and that segment, there's a lot of A53s and that class of devices now. So we started adding that, and now it's basically 32-bit bare metal embedded toolchain. It's released twice a year. One major release typically happens in the last quarter of the year. So in this year, it'll be September to December. And then there's an update release that happens just I think mostly in April to June timeframe. It's timed so that we can do a major release based on the .2 version of the GCC and the update release based on the .3 version of the GCC. So recently we did, first thing I want to call out is the update release, and that happened happened, I think if I remember correctly, May of this year. The two big features that came in was it was Mac notarized, the Mac version of it. It's a first notarization that we have done for the toolchain, which means it can be used on any Mac hardware today. And then we also added the 32-bit Cortex-A support, as I told earlier. One of the unique things we did this year, I mean, this is mostly one-off, we're not going to do every year, is we made the preview release available in June. And this is a preview release for GCC 10, and mainly for end users to try the new features in Cortex-M, the MBE support, and the custom data path extension, the CDE that was announced late last year. So that's the preview release that's there. And both of this are kind of available in our download site. If you're not familiar with it, let me quickly show the download site. So yeah, this is our download site, and you can find all the releases here. So from the Q2 and preview, and the release is going all the way back many years now. All right, what's coming next? We are going to do a proper release of the 10 series, which is called 10-2020 Q4 Major. It'll be GCC 10.2 based release, and it'll have the MVE and CD support. So we expect this to be shipped as part of IDEs next year. All right, that's the GNU embedded toolchain story. There's been a growing request, desire for having a similar toolchain based on LLVM. And we have started the work on it. It's going to be very, very similar to GCC bare metal toolchain. It's basically the same segment, assembler, compiler, linker, libraries, all that. And it's free to use. It's built on top of LLVM open source components, LLVM linker, LLVM debugger, and a whole bunch of those features, and then new lib for the C libraries. The alpha is available for kind of early access lead partners. If you're interested, please get in touch. We're working towards a public beta release in mid of 2021. So before this version of Linaro Connect next year, it should be available for anyone to try. This is going to be hosted on GitHub. I think at that point, we'll just open it up as a project as well. So this is in addition to GCC toolchain. There's no plan to stop GCC toolchain anytime soon. So for foreseeable future, maybe 2-3 years from now, you'll have both toolchains being released at almost the same time. Moving further, let's talk about the architecture support. GCC 10 was one of the big versions of GCC when it comes to architecture support. We had SVE intrinsic support added for the first time. Outline atomics, this was done by Linaro, which basically detects at runtime whether the hardware has LSE atomics 8.1, ARMv 8.1 LSE atomics or not. This has been since then backported to GCC 8 and 9, and has been found quite successful and useful in Neoverse N1 deployment so far. Then we added 8.6 support. So this is basically bfloat 16 and matrix multiplier extension, both intrinsics for A profile. For M profile, as you saw in the previous slide, we added custom data path extension and MVE intrinsics. So what are we doing next? We're doing MTE heap tagging, and stack tagging is going to be further out. Then we are doing SV auto-vectorization improvements, MV auto-vectorization. So GCC 10 did not support MV auto-vectorization. GCC 11 will support some MV auto-vectorization, and GCC 12 will have further support. And then the ARM AR64, ARM v8R support. So the 64-bit R profile support will add in GCC 11. There is a website, there is a web page that I maintain on developer.arm.com, and it contains not only the details of GCC, but also contains other components. I'll quickly show that it's been found useful by quite a lot of users. So I'll just go through quickly what this is. So It has M profile detail, A profile detail. For all the major features, you can see as to which version of binutils and GCC and glibc and GDB added support, right? So across all the different GNU tool chains. It not only has a status, which is captured here, but you can also see some stars. These mean that it's not released yet and it's planned for future. And wherever we have visibility, we make it public. So for example, MTE stack tagging, we are targeting in GCC 12. So we have almost roadmap visibility for up to 2 years from now. This is a page I would recommend to check if you want to know which version of GCC you need to use a particular architecture feature. Okay. So looking at performance side of GCC 10, GCC 10 was one of the spectacular versions as far as the performance improvement was concerned, especially when it comes to spec. There's a blog in which we've described what all has gone in. This is almost 10% uplift for GCC 10 versus GCC 9 spec int. And this is on Neoverse N1. We've seen similar kind of uplift on other platforms. And roughly half the contribution came from ARM and the other half came from partners, specifically Ampere in this case. And it's been one of the big movement. I think in absolute terms, 10% is what we might have got over last few years. All right, moving further, let's look at LLVM architecture support. So LLVM architecture support, we've got so LLVM 11, even though it's not been officially released, it's about to be released. There is release candidates that are available. So I'm just covering that. And you can see it's a similar kind of features that were added in GCC 10 are part of LLVM 11. For LLVM 12, we are trying to get the outline atomic support ported to LLVM as well, not just GCC, and the SV2 initial auto vectorization. So I'll give an example of what this initial auto vectorization means in a subsequent slide, but that's what is being looked at. Again, going back to the roadmap page that it's available on developer, it's a similar kind of page as GNU. So if I go to LLVM, so you not only get an idea of which version has what, but you also have a coverage of LLD and LLDB, which versions are happening. And the LLDB work is mostly being done by Linaro exclusively. And we are targeting a lot of LLDB enablement for key architecture features in LLVM 12. All right, coming back to the architecture support. So let's quickly look at the SVE, SV2 intrinsic support in GNU and LLVM. On the upstream side, we have GCC 8 supporting SV auto vectorization. So that's been going. That's happened in GCC 8. GCC 9 made further improvements. 10 is fully ready for any SV kind of work. It has full intrinsic support on auto vectorization. We continue to make improvements close to, whatever we found in Zeus relative to Zeus and Perseus, we'll try and get that in GCC 11. As you may have seen an announcement by ARM recently, both Zeus and Perseus have SVE. So those will be the first ARM cores to have SVE support. And we're trying to ensure that GCC 11 generates good code for that. On the LLVM side, it's been a difficult, long journey, I should say, but we made sizable progress. So with LLVM 11, you should have full intrinsic support, which means it's kind of on par with GCC 10 when it comes to intrinsics, assembly, and disassembly. For LLVM 12, we want to aim for the initial support of auto vectorization. And what I mean by that is we use TSVC, which is a kind of vectorization benchmark. It has a collection of different kind of loops. And the vectorization compilers measure themselves against how many loops you can vectorize. And in LLVM 12, our aim is we at least want to do one or more loops in TSVC. So our downstream compiler can do a lot. We just want to ensure that the upstream starts with one and then goes more and more. The goal is by LLVM 13, we should not have any gap between what we have downstream and what we have upstream. So all the things that we have downstream, we want to just make sure it's part of LLVM 13. So that's the SVE story. Moving further, LLVM Fortran. So this is another area, I mean, not relevant to embedded segment, but highly relevant for HPC supercomputing kind of segment. There's a project called FLANG that was originally started by NVIDIA team, and they open sourced it in 2017. It's the GitHub link shows where to go to get the sources of it. It has 2003 and 2008 support, but it was written in a different era, so it has different style, which is not compatible with LLVM. Hence, PGI/NVIDIA decided that they will write a new Fortran front-end from scratch with all the LLVM features, LLVM rules being followed. And that's was accepted in LLVM project, I think in 2019 EuroLLVM. And it was made as part of LLVM project early this year, April this year, I think. And the main contributors for that has been NVIDIA, ARM, and AMD so far. So ARM and AMD have been working on the OpenMP part of it. NVIDIA have been working on the Fortran 77 support. So there's a talk by NVIDIA at the upcoming LLVM Developer Summit, giving an update on where they are with the F18 project. So ARM ships commercial compiler. AMD ships their AOCC compiler. Both of them use classic FLANG as a front end. So we continue to maintain that and add fixes, improve debugging, because that's going to be the front end of a compiler for foreseeable future while the new FLANG comes on board. So the maintainers, it's a kind of a open source project where the maintainers are NVIDIA, ARM, AMD, and Huawei at this point. And if you're interested, please take a look at the wiki mailing list of the Slack channel. So it's a public open for all meeting that happens almost every week, covering different areas of the classic FLANG and the FLANG project. Right. That's the Fortran story. Now I'll quickly move to the Linaro toolchain working group proposed plan. I don't want to go through in extensive detail, but the slides will be available later, and all the links that are there are publicly available, so Jira links. So in terms of GNU toolchain, they continue to work on code speed improvements, both AR64 and AR32. Especially on the debugger, Linaro has taken a lead with working on GDB, both on the AR64 and AR32 side. On the LLVM toolchain, Linaro, for the first time, has started working on Fortran. So they'll start working on Fortran front end. And also for security sensitive applications, stack clash support, which is there in GCC toolchain. Linaro will start working on the stack clash toolchain. The goal is to complete the stack clash support by LLVM 12, which is the next LLVM. So they're going to work on that. Like I showed in the earlier LLVM toolchain roadmap, debugger is almost exclusively done by Linaro LLDB. And debugger architecture features all the way from 8.2 to 8.6 is kind of being worked on. Code size optimizations continue to happen, aimed at 32-bit bare metal kind of use case. The last big item that Linaro is going to be working on the next 6 months is, actually they've already started work on this, is the Windows on ARM native toolchain. So what this means is if you have a Windows on ARM laptop or Surface device, you will have an LLVM native toolchain by LLVM 12. And that's what we are planning. We're making good progress. Linaro has already been established. They've created some build bots. They've found issues. We and them are working right now to try and fix those issues. So we're confident that we will hit the LLVM 12 goal of having a native official toolchain. The details of this is available here. I mean, all these links are now open. They're all Jira links. They're all open. You can take a look at them, comment at them, or I mean, you can basically engage with the development team using those tickets. Similarly for LLVM, all the tickets are kind of publicly visible. So that's mostly what I had as an update today. And I'll share the links that I was talking about. So this is one of the most useful links I've seen partners benefit from, especially if you don't know which version of LLVM or GNU you need, depending on the architecture support. So, okay, any questions? Let's look at the Slack channel and see if there are any questions. All right. No questions. If you want to get in touch, you can use the Slack channel. I'll check later as well. Otherwise, thank you for your time.
All right. Thank you.
Thanks. Bye.
Bye-bye.